Assalamualaikum and good day. We are from LAT 183 Calculus 1. Today, our group will present the topic Techniques of Differentiation.
Before we begin, here are our group members together with our student IDs, program code and course group. My name is Nur Aziati binti Sari.
My name is Nur Shazina binti Sarul Baharun.
My name is Afifatul Huda binti Zafar. My name is Siti Nurmanifa.
In this presentation, we will explain the meaning of differentiation and discuss several types of differentiation, such as product rule, quotient rule, chain rule, implicit differentiation, and linear approximation. We will also solve all given questions step by step and explain why each differentiation rule is applied.
Lastly, we will conclude our presentation by discussing the challenges faced and recommendation for new learners. For question 1, we are required to explain the meaning of differentiation and the techniques of differentiation. So, what is differentiation? Differentiation is the process of finding derivative or rate of change of a function. As stated on the slide, it measures how one quantity changes with respect to another quantity. Several techniques of differentiation are used depending on the type of function involved. So, the product rule is used for application of function. The quotient rule used for division of function. The chain rule used for composite function. Implicit differentiation is used when x and y are mixed together. So for the last, linear approximation is used for estimation. These techniques are important because they simplify complex calculation, improve problem solving efficiently, and help solve real-life problems in mathematics, science, engineering, and economics.
Alright, so let's take a look at this question. Okay, so if we look here, the function consists of multiplication between two functions because we have ln x squared plus 1 multiplied by cosine of x plus 1. So this actually satisfies the rules to use the product rule, which is y equal to uv. So it will become u prime 1 over, rewrite the function inside the bracket, x squared plus 1. And then don't forget to differentiate the function inside the bracket. So it will become 2x to the power of 2 minus 1 plus 0. To simplify it, and then 2x equal to x squared plus 1. Differentiate it and it will become v prime. So for course, if we differentiate it, it will become negative sign. Negative sign, just rewrite back the x plus 1. And then don't forget to differentiate what inside the bracket. So, simplify. Negative sign x plus 1. X to the power of 1 minus 1 will become 1 multiplied by 1. So the final derivative of v is negative sign x plus 1. Okay, so next we can just substitute the value inside the product rule formula, which is dy over dx equal to uv prime plus vu prime. So let's expand one inside the bracket. So ln x squared plus 1 multiplied by negative sign x plus 1, it will become, let's expand cosine of x plus 1 multiplied by 2x over x squared plus 1. So it will become 1. Okay, you can either choose to leave your answer as it is, or you can move this function to the back because it has negative here. So I will move it to the back. 1. So this will be the final answer. Oh, don't forget to put bracket here. Okay, question 2b, we have y equal to tangent for x divided by y plus x squared. So as you can see here, the function involved division, we have to use the quotient rule, which is divided by v squared. We have to differentiate this function to get the v, u, v prime, and u prime. So differentiate u prime. If we differentiate tangent, it will become secant squared. So it will become secant squared. Rewrite for x, and then don't forget to differentiate what's inside the bracket. So it will become 4x to the power of 1 minus 1. And simplify it. This is our u prime. V prime equal to differentiate 1 and it will be 0. 2x to the power of 2 minus 1. Simplify. 2x to the power of 1. And then we just have to substitute the value inside the formula. So we just have to simplify this equation. 1 plus x squared, 4 secant squared 4x. If we expand this and simplify it, it will become 4. 1 plus x squared, secant squared 4x minus 2x, then 4x. And then don't forget, divided by 1 plus x squared. So this is our final answer for question 2b.
For question 3, we are given this equation and we are asked to find dy over dx. Because if you take a look here, we have the terms x and y. There are two terms mixed in one function, so that's why we have to use implicit differentiation. So we have to differentiate both sides. So let's take a look at each equation carefully. Our u is y, so we will have 1 over y multiplied by the derivative of y, which is 1, since the power of y is 1, and dy over dx. Since whenever we want to differentiate y, we have to include dy over dx. Okay, so we have cosine here. When we differentiate, we have to use this two, which will turn into negative sign u multiplied by the derivative of u. So our u here is this inherent function, which is x squared plus ey. So when we differentiate cosine, it will turn into negative sign our u here and multiplied by the derivative of u here. So 2s differentiate into 2, x squared differentiate into x, and exponent y differentiate into this eu multiplied by du over dx. Our u here is y, so ey multiplied by the derivative of y, which is 1 dy over dx. So we're done here. Now let's take a look at this equation. We have two functions here, x and y, multiplied by each other. So we have to use the product rule, which is u v prime plus v u prime. We have 2x multiplied by 2y dy over dx plus y squared multiplied by 2. So we will write here. So when we get to this point, let's simplify it first before we can move on to the next step. 1 over y multiplied by y is 1 over y dy over dx. So in this large bracket, we have two more brackets. So we can expand it one by one. X times negative sign equals to negative 2x sign x squared plus exponent y. Ey 1 times negative sign equals to negative ey sign x squared plus exponent y dy over dx. And then we can simplify here. 2x times 2y equals to 4xy dy over dx. Y squared times 2 equals to 2y squared. So when we have simplified all the equation, then we can track back to our question. We want dy over dx. So our strategy here is we can collect all the equations that have dy over dx to one side, and we collect all the other equations that does not have dy over dx to the other side, and all the other equations that does not have it on the other side. Then we can separate the dy over dx. Since we want dy over dx equals to what? So we can factorize the dy over dx out of all these functions. So we will have this. Now, since we want dy over dx alone as the subject, we have to move all this equation into this side. We can use division. So it will turn to this one. Now, this is our final answer.
For the question number 4, we use linear approximation to estimate the given value shown on the question. For this question, we use this formula. To find x null, we use the chosen value because it closest to the given value, which is 8.02. So we substitute on this question, we become this. Next, f(x) equals to fx and f prime x equal to f prime x. To find these two functions, we assume x equals to 8.02. When we write it back, it will become x squared minus 1 over cube root x. To make it easier for the next part, cube root x will become x to the power of 1 over 3, and bring 1 over 3 up here, and it will become x to the power of negative 1 over 3. Then we differentiate this equation. X squared differentiate will become 2x, and differentiate x to the power of negative 1 over 3, it will become 1 over 3 x to the power of negative 4 over 3. We simplify it until it becomes 2x plus 1 over 3 cube root x to the power of 4. In the next part, we use these two equations into this and substitute x into a. Become this. So, when you calculate using calculator, we calculate one by one. So it becomes 63.5 plus 0.32042, and the final answer will be 63.8204. In conclusion, differentiation is an essential concept in calculus that helps determine rate of change and solve mathematical problems efficiently.
Throughout this presentation, we discussed several techniques of differentiation. We also solved all given questions step by step and explained why each differentiation technique was applied.
One of the main challenges we faced was applying several differentiation rules on a single question, especially for implicit differentiation and chain rule question. However, through discussion, practice, and careful calculation, we improved our understanding of the topic.
We recommend new learners to practice regularly, understanding the content clearly before memorizing the formula, and solve the problem step by step to avoid mistakes.
Thank you for watching.